Good day everyone. So in this short videos I want to quickly show us how we can pick our components. This video is actually coming as a response to some of the comments I received that most of my circuits have been connected before I start my analysis and my calculations. So I want to do these short videos in response to that so that you know where to pick what when you need it. So I presumed you have installed Proteus simulation software, and having done that, when you launch the application by clicking the icon wherever you have saved it, whether it is on the desktop or where, this is the next environment you see. We call this the landing page or the home page of the software environment. Now when you want to create a new project, we have open project, new project. Open project is for an already existing project which you have done. So new project is where we are going to, because it is assumed that we want to create a new project. So let's say how to, you give your project a name, how to find your component on Proteus. So when you click on that, the path is where the application saved your work. So me, I'm saving in my document. So click on next. Do not create schematic, then create schematic. You have to create the schematic, because actually the schematic diagram is what you are plotting here. So you create schematic. Do not create PCB layout, create PCB layout. So I don't want to create a PCB layout. PCB is when you want to print your circuit on a printed circuit board, but I'm not doing that for now, so I'll say do not create. Create a firmware project. No firmware project. I don't need a firmware project. So when you are done, click on finish and you wait for your okay. So the system is back. So you see this schematic capture layout, and when you want to pick any component on the Proteus simulation software, you go to the P. Now there's a difference between this P and this L. L is for logic devices. When you click on the L, you see all the logic devices. You have seen it, different logic gate, AND gate, OR gate, timer, differential amplifiers, so on and so forth. So that is what that L does. But what we are interested now is the P, where you can pick all your passive components like resistor, capacitors, inductors, LED, multimeter, batteries, whatever you want. So let's say I want to create a simple LED light that will be controlled by a 24-volt battery. So when I go here, I type my resistor as the first component I will be needing. You need the resistor as a limiting resistor. So let me just pick a generic resistor. We have different categories of resistors you can pick from. So I want to just choose a generic resistor. When I double click the resistor here, it will appear at the device library. I want to pick what other things will I need. Let's say I want to pick a battery. I type my battery, say multi-cells, active DC voltage source. Let me pick this DC voltage source. Then what I need again, I will need LED. That's for the indication. So let me go and pick an active LED, generic active LED. Let's say active LED. Let me look for another color. Okay, this one is a active LED, was animated blue yellow with self flashing. Okay, let me go with this one. So when you are done, you click on okay. I need a switch. Yes, I need a switch. You type switch, you see active switch, single pole, single touch, single pole, single touch, SPST, active single port, single touch. So having done that, so let's try to connect our, let me start from the battery. When I click my battery, you place it 12 volt. Then you need your switch. You need your switch. Let me place my switch. So let me place my, what other things, my resistor. So let me place my resistor. So what do I need again? Let me place my LED. My LED, let it be around here. So you can now connect everything together to your switch, the output of your switch to your battery, then the output of your resistor to your LED light. Then the circuit is completed. So to get a grant, you right click anywhere, click on place, go to terminal and grant. You can place it here. So now let's try. If you want to run the simulation, let me say I want to assign a value of 24 volts to this supply. I want to make it a 24 volt supply. Now I want to give it a name. Let's say supply. So I want to change the name to supply. Then this resistor, I want to change the name. Double click. I want to change it to limiting resistor. I want the name to be limiting resistor. So if you simulate this work and you toggle the switch, the LED should turn on. You are seeing that there is the color change. So let me maximize it. So you are seeing that the color is changing. So that's to tell you. But occasionally, in most cases, you may need to change the value of this resistor to a low value. You need to change the value. I've seen that. You see that when it was 10 kilo ohm, the brightness was low because that resistor is actually a limiting resistor, and a limiting resistor controls the amount of current that flows into a circuit. So this 330 that I put is the usual values that most of a limiting resistor for this type of LED used to carry. So 10 kilo ohm is pretty too much. It's limiting the amount of current. The current that flows into the voltage that gets into the LED is too low with 10 kilo ohms. That was why when I changed it to 330 ohms, the voltage, the required amount of voltage, the maximum amount of voltage that needs to give this LED the correct power flows through it. So that is that on how to connect component. Now you may want to measure. Let's say for example I want to know the voltage across the resistor. I want to know the voltage that gets to the LED and so on and so forth, and the current. So when you click on virtual instrument, you see ammeter, AC voltmeter, AC ammeter, DC voltmeter, DC ammeter. So let's start from a DC voltmeter. If I click on DC voltmeter, I can simply measure the current, I mean the voltage across this resistor, and the voltage across the LED. So let me try to rotate this. Let me rotate this. Okay, we have done that. So let me connect the voltage. Remember, in your secondary school physics, you are told that voltmeters are to be connected in parallel to any circuit. So I want to measure the voltage of the LED. So if I run my simulation again, I should see the voltage that is dropped. You can see that the voltage that got to this is around 2.5 voltage. 2.5 volt. That's the voltage that actually get to this LED. So which means it required something around 2.5 volt as the maximum voltage. You can equally measure the current that is flowing in this circuit by putting, let's try to break this. If you want to break this circuit, you can just click on this arrow, then you click on any terminal where you want to break it. I want to put this ammeter. So if you put this ammeter, if it's not coming, you have to click that in again. Okay, put your ammeter here, measure it. Let's measure the current that flows here. So if I want to, you can